everyone and welcome. So, title of this presentation is maybe a bit misleading because maybe you think that we are going to talk about like how to take ownership of a project on a hostile way. But we are not going to talk about that. So we're going to talk about situations that happened to me a couple of times in my career. And this is when you, for example, join a new firm, join a new team, or for example, your team gets another project. So when you get the project, there are like two possibilities. Whether you are working on an existing project run by someone else, or you are lucky, you get to work on a new project to build a new application. Well, we are going to talk about this when you get an existing project. Then when you get the project, there are two possibilities. You can get a good project, or you can get a project that needs our help. We're not going to talk about that it is a bad project. We're going to talk that it needs our help. So when we talk about whether it is a good or bad project, let's differentiate those two things. So from my point of view, a good project is the one that has the pipeline correctly implemented. So at the slide, we have a continuous delivery pipeline, and we have build phase, test phase, acceptance test phase, deploy to stage, and it is all automated. But this pipeline sits on a good continuous integration, a good foundation of continuous integration. So the developers did their job. They automated build and test phase, and also DevOps give their part of the job, and they automated everything. If you, for example, if you are now in a new team and you get a project like this, then just continue work of your predecessor and everything will be okay. So let's talk what for me is a project that needs our help. Well, project that needs our help is the one that doesn't have the pipeline correctly implemented. So as you can see, I put this continuous X because I don't know how to say. How should I say about this pipeline, what is it called? But it is missing I would say, the most important part in the project, and that is test phase. So developers, they automated build tools, and then what the DevOps try to automate whole pipeline. But you cannot automate people to write tests. So this is what are we going to talk about today. We are going to talk about how to take ownership of a project that needs our help, that doesn't sit on a good foundation of continuous integration, and how can we approach to this problem and like navigate through these waters carefully and in a better way. So we are now unfamiliar with the project. So we joined a new team, we joined a new company, and we get a new project. And it is not the best project. It is a project that needs our help. So let's get familiar with the project. So when you are in this part of stage, when you are overtaking someone else's project, you want to learn about the project as fast as possible. So how are we going to do that? We are going to get familiar with the project by getting your hands dirty. So from my point of view, this is the best approach. So let's start. So there are also like two ways we can start with this problem. So we want to learn as much as possible about the project as soon as possible. So there are two possibilities. We can start with keeping our hands clean. So this is, for example, you get a new project, what do? You read documentation thoroughly. You clone the project, build the project, run with the application, and then we have a question and answers phase. And you are ready to start coding on a project that needs our help, that we don't know how it works. Well, I'm not sure that you are ready to start writing implementation and feature requests and to solve bugs. What I advocate is to get your hands dirty And how are we going to do this? Well, we cannot jump and write the code immediately. Why? Because we don't know how the application is behaving. And from my point of view, I'm not comfortable adding changes to the project that don't know. So what is the best approach? The best approach is to, well, again, you go to documentation, you build the application, run the application, play around, and then where can you write something that is not going to affect the implementation? You can start writing tests. So why is this the better approach from the documentation, reading only documentation? Well, the documentation rarely follows the implementation. And also, documentation doesn't fight back. What does it fight back? Code. So for example, I remember in my early career, I was fighting with soap services. I didn't put a flag, and it took 1 month to figure out what was wrong. So the code will fight back. So with writing a first integration test, you will not learn only how the application works, you will learn how the application works under the hood. And also documentation. Well, you're not going to put documentation, all the bad stuff about your application. You're going to put only good stuff. But with writing your first integration test, you will learn a lot about how the application behaves. You will learn a lot how it's implemented under the hood. And then you can start documenting your findings and then later have question answers. Why? Because those are your questions. And if, for example, you have question answers before, those questions will be reasoned by someone else. So we want to become familiar with the project. So we know that we are going to do this by getting our hands dirty. So and then we know that by writing our first integration test, we are going to learn a lot about the project. So again, when you get a project, the project can be built using a framework with good testing support, and also it can be built by a testing support with a framework without good testing support. So let's start with this first scenario. So let's start with the project. Let's get familiar with the project using a framework with a good testing support. So I come from Java world, and for me, Spring Framework is an excellent framework with a good testing support. Why is it it is a framework with a good testing support? Because it doesn't require you to build and run the application in a separate process. In the end, it makes writing tests easier for you. You don't need to, for example, for me, framework with no good testing support is the one that you need to build and run the application in a separate process in order to write integration tests. So let's start with how we're going to get familiar with the project who is using, for example, Spring Framework, which has a good testing support. Well, we are going to use capabilities of framework. We are going to start with a simple integration test saying hello with an empty properties file, and we are going to watch it fail. So why are we going to start with simple integration test and not unit test? Because we want to see how the application will behave when all bins are wired together. So why are we going to say hello? Remember, we are just learning about the project, and we don't have requirements. We only have our wish to learn. So this is why we are going to start with hello world. Also, why? Because we want to build the integration test, which will then used as a baseline, as a foundation on which we will build the continuous integration. Why are we going to start with an empty properties file? Well, maybe I'm this is too much. You can take properties file from production and start it with that. Why are we going to do it with empty properties file? Well, we want to learn as much as possible about the project. So we will, for example, and for sure it's going to fail first time. Why? Because it's going to miss, for example, your application is using database. For sure, your first integration test will fail. And then what? You will go look under the hood your classes, and then you will see that your application is using database. For example, that your application is using migration scripts or not. If your project does not have migration scripts, go to the production and use it as a baseline on which you will then later write your code and integration tests. Then, for example, let's assume that the database was missing. Then our unit integration test will get fat. We'll put more and more into this integration test because why? We want to build the test context and we want that our application says hello to us. Then we will configure our database configurations. And then, for example, it will for sure fail because we are using some REST APIs. And then you will learn that our application is using some third-party system to go and to fetch some data. This is very useful, for example, because in one project it was configured, so clients were configured to eat exceptions. So, for example, you got 400 or 500, and the exception wasn't risen. So you will learn a lot. So yes, you needed to ask the client to give you status code, and then if it's 200, everything is okay. And for example, if it's 400, 500, then you would throw exception. So you will learn a lot by doing this. You will learn how the application is behaving under the hood. And iterate this until the application says hello. So you will learn a lot in this process. You will learn how to build the application, run the application. You will learn how the application is configured under the hood. So this is what is important. In documentation, you will not find this. In documentation, you will only find like a sunny place with everything is great. But if you start writing integration tests, the code will fight back and you will learn a lot about the project. So we are now familiar with the project with the good testing support. Let's touch how are we going to be familiar with the project using a framework without testing support. So as I said, framework with a good testing support is the one that does not require you to build and run the application in a separate process. But for example, Java Enterprise Edition on which I was working 7 years ago is for me an example of a framework with without testing support. Why? Because you need to build and run the application in separate process. So it makes writing tests harder for the developers. Thus, you're not going to write tests if it's hard for you to write tests. So how are we going to approach this problem with writing our first integration test with the framework with no testing support? So we are going to look at the application as a black box. So what are we going to do? We are going to look at it as a black box. We are going to automate local deployment, so build and run phase. Why? Because continuous integration promotes automatization of everything. So automate everything where you can get some time, because it's going to give you a feedback faster. Use repository layer for putting and getting the data from the database. So when you are writing integration test, you need to prepare the application with the data in the database, and then you need to assert what the application did. So I have seen that, for example, the people are using SQL commands directly. But why don't we use repository layer? Because it is used in production, so I think it's also it can be used in writing tests. It's going to be easier for you because you are using something that is proven that it works. So this is how you approach when in writing your first integration test when you are dealing with framework with no testing support. But this has some drawbacks. So it's good, but it's not the best solution. Why? Because, for example, if you change a couple of classes, you need like 5 minutes to get a feedback whether your test is working or not, whether you have broken the existing implementation or not. So I use this approach plus the one I'm going to tell you when I was working with such a project. So I was using this approach, for example, for writing tests for existing capabilities, and I used the, this approach to, for example, to speed up the feedback, getting the feedback for the new functionalities. So, as I said, Java Enterprise Edition is also excellent framework. It has dependency injection and everything. So, if when you want, what is like our intention with this? We want to get feedback faster. So how are we going to get feedback faster? We don't want to put it on an application server. We want to build our context manually, starting from the database layer to get the feedback faster. Why are we going to go with the repository layer? Well, we need to start from somewhere. And we build also this repository layer in the first approach. So when you are adding new functionalities in such project, just build your context, build layer by layer as you add new functionalities, and with this approach, use this approach for new functionalities, for the existing functionalities, because in a project that needs our help, well, you can find a lot of spaghetti code. But you don't need to continue with this practice. You can, for new functionalities, you can start with a new clean start. So use this approach for the existing, for the new functionalities, and use the first approach when you look at the application as a black box for the existing, for testing existing functionalities. So we are now like, when you write your first integration test, you will get familiar with the project. You will get knowledge about how the application works, how it works under the hood, and also what you will do, you will build a foundation on which you will build the other tests. So we are now familiar with the project. Let's start making comfortable with the project. So how are we going to become comfortable with the project? When I'm talking about comfortable, I mean adding new functionalities, refactoring the existing code, and then, for example, bug fixing. So how are we going to do that? We are going to do that by implementing CI and making other write tests. So it is easy, for example, if you're working alone on the project and to implement CI, to write more tests. But what is the biggest challenge is that you need to make others write tests and that they are happy about that. So we are going to touch how are we going to make other write tests and they are going to be happy about that. So there are like a couple of steps we need to do in order for others to make others write tests. And the first thing is first that you need to make writing tests easy. So easy like plug and play by putting all common stuff in one place. So in that exercise, when we were talking about the Spring, we were building this integration test, and there was a lot of boilerplate in which we configured database, in which we configured external mocks and test context. We will use this, we will put this in a separate component, and then we will just plug new tests. Why? Because each test will need, for example, database creation, building a test context, and external mocks. So for example, on the following slide, you will see how it looks in our firm. So for example, you have like test is like 3 lines of code only. We have seed with dataset in which we are putting something in a database. Then what we are calling a web test client and deleting something. And then in the last step, we are verifying something. So this is the goal, how we want that our test looks like. And you are going to do this by putting everything common in one place, and then writing tests will be easy like this. So this is the first. So you need to make, first step, you need to make writing tests easy. Why? Because if it's hard, no one will write it down. The second approach is, for example, use specification by example to describe the system behavior from client's point of view. So specifications are required. Why? because we need to tell developers what we want from them to build. And it is hard. Why? Because people who are writing specifications are usually developers. And developers are what? They are looking how it's going to implement under the hood. And this is not what developers want to, that someone give them the solution of the problem. They want that you describe the problem and that they have freedom to write the solution of the problem. So why are we going to look from the client point of view? Well, writing specification, it requires a good balance. For example, you need to describe system, how it should behave, but we don't want to see how it's implemented under the hood. And who is also interested in such information? Client. When you're integrating with someone, the client needs to know if I give you X and with these preconditions Z, you will get Y. Y, yes. So this is why and how. So we need to look at the system as a client. And this specification, by example, is, I have been working for 11 years, and this is like the best approach I have used, and developers like this approach. So this is similar to behavior-driven development, but without cucumber and stuff like that. So let's see how are we going to, for example, describe the developers, what we want from them to develop. So this is going to be a very simple scenario. We are going to describe, for example, how we want the developers to create this post promotion, so API, in which we just want to save promotions to the database. So we are going to look at the application as a black box, and we are going to try to describe the system behavior. So don't assume the developer will cover all cases. So why? We don't read each other's mind. I don't know what you are thinking now. You don't know what I'm thinking. So also the developers. So for example, if you tell them, cover all cases, okay, great. I have 3 cases, you have 20 cases. So you write down everything. So for example, let's start with how are we going to describe what we want from developers. So start with the given. So we have preconditions. Application and database is up, database is empty, and only payment type 1 and payment type 2 are allowed. If I'm posting a promotion to this API, and the promotion DTO we have ID 1, coupon serial number is 10, and we have payment type 2. So then you describe what the application should ignore the ID provided, save promotion to database, and return promotion DTO 201. So for example, if we want that the application returns 200, we would put it like this. So let's go to another example. Application and database are up, database is empty, only payment type 1 and 2 are allowed, but I'm going to post a promotion with payment type 3. So application should return 400 better request with message payment type X is not supported. So the second one is, for example, that we are going to, let's start with given. So we have application and database are up. Database is not empty. We have one promotion item in the database. So we have ID 1, coupon serial number 10, and payment type 1. Everything is okay. So we have one entity in database. We are posting the second one with the same coupon serial numbers. And then the application should what? Return 400 with error code, and message promotion with the provided coupon serial number already exists. List everything. Especially bad, not only valid cases, but also the invalid cases. Why? Because again, the developer doesn't know what you want from them to do. So if you write them down, the developer will know, and both parties will be happy. And so this is the second step. So you need to write down all the cases. The last step is make automated test proof that the developer has covered the case. So each action, so if you have input, for example, I give you a task, for your task, there should be an output. And for the developers, they need to implement stuff and test stuff. The proof that you have implemented something is What? Source code. And the application, that application is working. What is the proof that you have tested something? I'm not going to believe you. You need to write down the test, and this is how I'm going to trust you that you have actually covered this case. So for example, when I'm doing the code review, I'm just looking at the implementation, whether it is following clean code practices. And then what I do, I don't like look if whether all the cases are covered. I look whether all test cases were covered in the test source. If it's covered, then you can go. Because for me, it is more important to have tests than, like, I would rather have bad code with good tests than to have good code without test. Why? Because in 10 years time, you will not remember what you did. So if it's working, don't touch it. But for example, if I want to change it, I would rather have test than to have like a good code which I don't understand. So in 10 years time, I'm not going to understand anything. So it's better to have a documentation in a form of a test than to, for me, this is my personal opinion, I would rather have tests than to have a good code. So this is it. So this is how we're going to make developers write tests. And to be honest, in our firm, it works pretty fine because developers are happy because they know what they should implement and how they are going to verify that everything is okay. So now, when you implement the CI and make other write tests, you will become comfortable with the project. But we are not yet confident to do what. We want to also be confident to optimize existing functionalities. When you implement CI, you will be comfortable to add new functionalities, resolve bugs, and do a little bit of refactoring. But you're not going to be confident to optimize existing functionalities. Why? Because most of the projects, most of the firms, they have a system, and a part of system, it is making money. No one knows how it works, and no one is touching it. Why? Because we are all afraid to touch that stuff. But now, if we leave this part of the system alone, then we are not going to drive it forward. And we want to be confident to optimize those stuff also. So how are we going to do that? We are going to do that by using feature flags. So let's assume that you have a project and the time has come for you to change this part of the code that no one in the firm knows how it's working. So how are you going to do that? So you have existing implementation, it's working. So you start with what? You write unit tests, integration tests, and then what? You put it in, then you release it, give to QA to test it, and then you go to production with this version. So, sorry. So you have existing, you write tests, then you have a new implementation, you run the test from this existing on new implementation, you release it, put it into production, put on a QA, then the QA say, okay, let's go. And then you go to production and that doesn't work. So there is a better way for that. So how are you going to do that? Well, guys, we have two implementations, one that is working and one that might work. So what are we going to do this? What are we going to do? We are going to put the both implementations in the code and manage the application flow with feature flags. So what are the feature flags? The feature flags are essentially Boolean flags in the code in which we are going to manage the application flow in runtime. And how are we going to get the value of the flag? We are going to do it like the simplest way is to put it in database and to fetch on each request to database and to see how the application should behave. Well, this is like the simplest way. So there are like a lot of other possibilities how we can do this. And why is this a good thing? For example, if you put if you put both implementation, well, you have a fail-safe mechanism. If it's working, great, you have a new improved implementation. If it's not, go back. So for example, in this example, if this feature is enabled, then execute new implementation. And for example, if it's not working, fall back to all the old functionality. And why is this also great? For example, if you have a team that, for example, when you learn that you cannot trust yourself, that it is going to work, then you can also be aware that you are not going to, for example, you have a team that you are not, that you don't trust. So for example, that team exposes a new API, new approved API. Just put it in production, turn it on. Okay, if it's not working, just turn it off. It's like that. So with these feature flags, you can configure your application runtime. So for me, for example, you just need to embrace possibilities that you can make mistakes, but the client doesn't need to know that you have made a mistake. For me, it's better to have, for example, with this feature flag, you can control how many features you can have turned on in the production. For example, for me, it's better to have 70% of the features than to roll back the whole application. For me, it's better to have 70% than to have 0% of the new features. So you can do this by feature flags. And for me, it's like the best mechanism. So thank you, guys. So my name is Igor, and this was my guide how to take ownership of another person project. Thank you.